such that it satisfies this condition, f of x is less than g of x and less than or equal to h of x, then if the limit of f of x is L, it approaches to L, and the limit of the g of x approaches to L, then the limits of h of x is approaches L. That's why the middle. We have three functions. This is the middle one. The middle one. Therefore, then example, if we can check this one. At the place of f of x, if I have taken 1, at the place of g of x, let's say I have taken sine x over x, and this one is less than or equal to cos x, then the limit of f of x is 1, the limit for f of x 1, and the limit for h of x, which is cos x, as x approaches 0, is 1, again. Then the function at the middle, which is sine x over x, will be 1, as x approaches 0 is also 1. This is the first example of the special limit. This is why the limit we say 1. So having these 5 or 4 examples of special limits, so we will see different examples which satisfy or calculated better up or the special limits for the next one. X plus 1 over x plus 1 over x plus 1 as x approaches minus 1 is equals to 1, because if we substitute minus 1 directly, it gives 0 over 0, which is indeterminate, but using the special limit, it is 1. So, or the limit of sine x plus 1 over x plus 1 as x approaches 1 approaches to 1. Be careful now. Be careful. Here, these conditions happen, or it gives 1 if satisfies two things. 1, the expression looking over here, and the expression looking at the denominator here are the same. Second, as x approaches to a number, some number a, which makes 0 over 0. Therefore, this limit, in order to be, the limit is 1, it should be satisfied two things. The expression here, both of them should be equal, and again, the approaches to the number that makes both of them 0 over 0. Let's say, if you substitute minus 1 plus 1 is 0, sine 0, 0. And again, at the denominator, if you substitute at the denominator 1, minus 1 plus 1 is 0, then 0 over 0. Therefore, second one, the expression at numerator and denominator are equal. So at that time, it satisfies both conditions. So the limit approaches to 1. Else, it needs further explanation if it violates this rule. Let's say example 2. Let's say it does for this one. Sine of tan x over tan x. X approaches to 0. So the expression over here is tan x within the sine, and again at the denominator is tan x, which is the same. As x approaches 0, directly substitute to tan 0. Tan 0 is 0, then sine 0 is 0. That's it. Then 0 over the same thing. If you substitute it to the denominator, tan x, which is tan x, then as x approaches 0, then tan 0 is 0, then 0 then it gives 0 over 0, which satisfy one condition. Again, the expression I have here, we didn't sin x, I have tan x. Again, at the denominator, I have tan x. So the limit approaches to 1. The limit approaches to 1. Again, the third example. As x approaches pi over 2, sine into cos x over cos x, the same thing. The expression over here is the same. Again, if you substitute pi over 2, cos pi over t is 0, cos pi over t is at denominator 0. That's why sine 0 is 0, and again cos 0 is 0, then it gives 0 over 0, the expression, as well as it satisfies the condition, the limit will be approaches to 1. This works if it satisfies the key, those two key important cases. Else we cannot say that the limit approaches to 1. If violates what it should be, then we'll take another corrections. For example, of these three examples, example 4 is different. Let's see. For example 4, limit of sine 3x over 4x as x approaches 0. If we substitute 0 directly, it gives us 0 over 0. Yes, but we cannot say 1 like the above example is, because the expression with the sine x 3x and the expression at the denominator is 4x, which are different expressions, which violate the rule to say 1. Then we will. So we will divide each term in the above by 3x, and for 4x by 3x. So we have the quotient of two limits, then limit of sine 3x over 3x, again the limit of 4x over 3x. In the above, it satisfies now the two conditions. The expression I have here, sine, which is 3x over 3x, okay? Again, if we substitute 0 directly, it gives 0 over 0. So the answer is 1. That's okay. Again, for this one, which is another function, you will cancel x by x. So you will have limit of 4 over 3 as x approaches 0, which is constant number. Then the limit of constant number itself, which is 4 over 3. Then finally I have 3 over 4. It approaches into 3 over 4. That is not approaches to 1. Why? Because this is not equivalent with 1. This is why it violates the two rules. The expression I have seen over here is 3x, over the denominator is 4x, so we cannot say 1, but it needs further another calculation. In general, if you encounter such examples, which has in general such this one, which is the limit of sine ax over bx as x approaches 0, so your limit is approaches a over b. You can generalize by this one, which means that if you so if you have like this encounters, for example, if you have sine 3x over 4x, the answer is 3 over 4x. If you have 6x over 5x, your answer or the limit approaches to 5 over 6, and so on. In general, if you have a kind of like this example, so directly you can say simply overlooking the number, the coefficient for this one is a and the coefficient for this one is b, so indirectly the limit is a over b. You can do like this. So another additional to this one. Okay, and this one is the limit tan 3x over 3x as x approaches 0. This is the family of trigonometric function, so I can express as tan x is the quotient of sin x and cos x. So this is what you call by tan x, tan 3x, and I have here 3x. Then this is I have multiplied by 3x. This multiplied. That's why I can separate like this one in order to use the above special limit. Then I have arranged like sin 3x over 3x as x approaches 0 and times limit of 1 over cos 3x as x approaches 0. Since this is the property of limits, so by the special limit, this is 1 again as x approaches 0, cos 3x is cos 0 is 1, cos 0 is 1, then 1 over 1 is 1, then the limit is 1 times is 1, which is the limit for this one, which means that the limit for this one, again the limit for this one is 1 again, then 1 times 1 is, the limit is exactly 1, so which is directly the same is true. Tan 3x over 3x is 1, tan 4x over 4x, tan something over something, which is it that satisfies with this one. But example 2 is different, the same procedure but different. I can explain like example 1. Since tan 5x is the quotient of sin 5x over cos x times 1 over 4x, so I can calculate the limit